All right, good morning, good morning, good morning. Good start in about a minute. All right, here we go. Welcome to the last class before spring break. All right. Any questions on last night's homework? Make sure everyone you are in fact turning in your homework. A couple of you aren't, and I put zeros in the grade book and you already have Fs. That's crazy. Quarter just started. Any questions? All right, let's go over the answers if there are no questions. Let's see, it was 1 through 13 all. 1 through 13 all. Question number 1. Name all pairs of corresponding angles. So that would be L and R are the same, O and I are the same, and G and T are the same. Question number 2, all pairs of corresponding sides. So side LO and side RI are corresponding, OG and IT are corresponding, and GL and TR are corresponding. Now remember, if I said LO, that's the same as OL. Okay. Number 3 should be IT. Number 4 should be RT. Number 5 is true. Number 6 is true. Number 7 is true. Are they all true? No, because number 8 is false. Number 9 is true. Number 10. Wait, time out, everyone. I just was calling out the class exercises. Nobody stopped me. All right. Let me start that again. I apologize. Written exercises. Here we go. Sorry. Number 1 is RQ. Number 2 is QP. Number 3 is 9. Number 4 is 10. Number 5 is 104 degrees. Number 6 is 48. Number 7 is 25. Number 8 is 50. Number 9 has 2 answers, but they're both 65 degrees. Number 10 is 1/2, 1/2. Number 11 has 2 answers. X is 5 and Y is 9. Number 12, Y is 3 and X is 20. And the last one, Y is 25 and X is 27. All right, sorry for that mix-up. I'm surprised none of you said something from the very start. Okay, make sure, like I said, you've turned in homework. A few of you are not doing that. We're going to do a repeat of what we did yesterday, which is to make sure this is solid. And then there is a worksheet. This is the last of the chapter right here. So everything that we've done so far, which was a lot, most of it was on Pythagorean theorem. And then this very last part right here was on similar triangles or similar polygons. And then we also had one section on cube roots. So when we get back, going back one slide, we get back, we're going to do 2 review days, and then we're going to take the test. Okay. If there's anything that you guys struggled on throughout this chapter, we got all of spring break, right? Send me a chat, send me an email if you need practice. I can generate as many worksheets as you would like for practice on this. And then we'll come back and we will practice the entire chapter. But if there's something you know that you didn't do well on, cube roots, Pythagorean theorem in 3D, let's use this time of spring break to fix that so we can come back and we can start off the quarter with an A on the first test. Here we go, similar triangles. And although it's called similar triangles, this also applies to any similar polygons, similar squares, similar hexagons, that sort of thing. But yes, this chapter or this section right here does refer only to triangles. All right, here we go. It is a practice day. For some of you, hopefully it changes from yesterday being a tough day to a bit easier day. I started off by saying yesterday that we've been dealing with nothing but right triangles, Pythagorean theorem. And then today we introduced the other two triangles, acute and obtuse. And the idea is this idea of enlarging or shrinking an object, in this case a triangle, but not changing the way it visually appears, right? We change that one little small triangle into a larger triangle, but we don't turn that acute triangle into a right triangle or an obtuse triangle. We keep it the same shape. So the shape stays the same, but its size changes. And in math, that's the idea of similar. Those two shapes right there are similar to each other. What differs is their size, right? And then the definition of a similar figure is it's exactly the same shape, just a different size. It's either been enlarged or it's shrunk. Okay? Those two triangles right there have either, depending upon if you went from the left one to the right one or the right one to the left one, have either been enlarged or they've been shrunk. Okay? We have a symbol that we use to indicate that two shapes are similar, and it's the tilde, T-I-L-D-E. And that one tilde, remember two tilde, one above the other means approximately, but one tilde means similar. Okay, so we would say the triangle ABC is similar to triangle DEF. Recall I started this by saying, we have basically four symbols now we use that compare a left side to a right side. So that symbol, the equality symbol, means that literally the value on the left of it is equal to the value on the right of it. Any of the inequalities don't mean that. They mean the opposite. They mean that the left side does not equal the right side. We have the congruency symbol. Then we're not talking about values, we're talking about shapes. So the left shape is the same size as the right shape, right? Same size and it's the same shape. Okay? And then lastly, what we've come to is that we'll have a left side and a right side, that the left side is similar, or the shape on the left is similar to the shape on the right. And what I mean by left and right, I mean the left side of the equation or the left side of the congruency statement, the left side of the similar statement is similar to the shape on the right side of the similarity statement. Okay, so similar figures, it turns out you have two consequences. The consequence number one is that the two shapes are similar. We're dealing with triangles today, that all of their angles that correspond to each other, they are also congruent. So here's what that means. Now we went from the one on the left there, we increased its size, but we did not change the angles. And yesterday, I think I drew this little shape right here. If you think about angle C right here, right? And we extend the legs of the angles, eventually we would make the same shape as that triangle DEF. Now they're the same size. But I didn't have to make the angle bigger, right? I kept the angle exactly the same. And that's the idea of the fact that consequence number one is that the angles stay the same. Whatever the angle was originally, when you make it larger or smaller, the angles stay the same. So that angle right there, angle C, is the same as angle F. That angle A right here is the same as angle D. And that angle B right here is the same as angle E. We can get that one of two ways. We can either get it because we're told that the two triangles are similar, or we can use this thing right here, which is called a similarity statement. And a similarity statement tells you that whatever the first letter here is A, that means angle A is congruent to the first letter over here, angle D. A and D match up. They are the same angles. The second letter here, B, is the same as the second letter here. So angle B and angle E are the same. And then lastly, C is the same as F. All right, so consequence number one, the angles are the same. So A goes with D, B goes with E, C goes with F. You can get that either from the picture. Sometimes they'll flip it around on you. It's a little bit challenging. And if they give you a similarity statement, I don't even look at the picture. I go right for the similarity statement. So the first game that we got from this is the fact that they will give you two similar shapes, two triangles here. One of them has been turned or twisted. They will give you a similarity statement, and then they will give you two angles and ask you to calculate a third. How is this played? Well, you simply fill in the information of what you're given to the appropriate triangle. You will have one question here. The question here is find the measure, M means measure, find the measure of angle E. So that's going to be my question mark. That's what I'm trying to figure out. So I plug in what I'm given. Let's see, what am I given? I'm given the angle A is 60, and angle A, first letter. So first letter corresponds to first letter. So A and D are the same. So if A is 60, well, then D is also 60, right? Second statement, if C is 70, B corresponds with, I'm just putting a question mark there. If C is 70 and C is the last letter, it corresponds with the last letter of the congruency statement. C goes with F, so F is also 70. Lastly, we will combine this information with the idea that all of the angles of a triangle add up to 180 degrees. So all of the angles added up, all three of them, add up to 180 degrees. So we can use that simple fact to do a little bit of math, add up the other two, subtract it from 180 to find our final answer. Now, we did this one yesterday. Are there any questions? And these are the first type of questions that they will give you for homework, which is they'll give you two of the angles and you got to figure out the third one. Now they can mix these up, right? They can put one angle on one triangle, one angle on the other triangle. You may have to do a little bit of matching up of corresponding angles, but they still will give you, unless it's a right triangle, they can be tricky, right? They give you a right triangle, right? They can give you one angle. So say this one's 40, and they're like, well, they only gave me one angle. No, they actually gave you two, because remember, a right angle is equal to 90. So they gave you two of the three angles. Add the two up, subtract from 180. Questions, anybody? Okay. All right, be careful of the ones they flip and they turn on you. Your natural inclination is just to match them up with your eyeball. If they give you a similarity statement, go with the similarity statement. It just makes your life easier. So A goes with D, B goes with E, C goes with F, right? When I typically tackle a problem like this, I go immediately to the question. It says find angle F. So I'm trying to figure out this angle right here, angle F. Now I plug in what I got, right? A goes with D, and A is 40, so D is 40. B goes with middle letter, goes with E, and if B is 50, well, then E has got to be 50. Therefore, I have two of the three angles. 40 plus 50 is 90. Subtract that from 180. That's a 9. 40 plus 50 is 90. Subtract 90 from 180, you get 90. I feel like I'm going a little fast. Are we okay? Nobody's complaining. All right, moving on. All right, this is the one that's a little bit weird, right? It looks like the same thing, but they're going to give you some strange information here. All right, here are the three things. Well, they gave us two of the angles, and they're asking for a third one. So let's see. A is 65. A goes with D, so D is also 65. C is 55. C goes with the last letter F, so C is 55. F is 55. 55 and 65 are what? What was that? 120, and 180 minus 120 is 60 degrees. There we go. There were three problems right there, all done with the same basic idea. Those are the, this is the one I was thinking about. The previous one wasn't that bad. Notice what we're given A and E, so we're given one angle of each triangle. We're trying to find angle C. So we're trying to find that angle right there. I'm only given one of the angles, and the other one is at 90. So we're told A is 40. Okay, but that was easy enough. We're told that E is 55. Well, E is on the big triangle. I don't care about the big triangle. I'm only caring about the little triangle. but angle E is the middle letter. Angle E would correspond with angle B. Okay, so B and E are the same angle. So if E is 55, B is 55. And now you can kind of see what we're doing there. Okay, so let's see, 40 and 55 are 95. 180 minus 95 is 85. Questions on anything we did? There was consequence number 1, that angles of similar triangles are congruent to each other. And I should say corresponding angles of similar triangles are congruent to each other. All right, let's look at consequence number 2. I did have this one up here. This is the one. Jace, you should be an expert on this, right?
Yeah.
Yeah. So on this one right here, let's see, we're told that angle A is 15 degrees. Well, angle A is on both the small triangle and the big triangle. And you're like, well, what do you mean small and big triangle? Notice I've got a smaller triangle right here in red, and I'll do it in, I don't know, blue. I have a larger triangle right here, and they both share the same angle, angle A. So angle A on both triangles is 15 degrees. And then I have these right angles right here. So here's your second one. So this one's 90, and this one is 90. So it says find angle ABC. ABC, remember we go to the middle letter to find the vertex of an angle. So we're looking for this angle, angle B, and this angle, angle D, right? And so basically I'm looking for that angle and I'm looking for this angle. And both, oh, by the way, B and D are exactly the same. They're the middle letter of our similarity statement. So therefore they are corresponding, they are congruent. Find one and you got the other one. So I don't care which triangle you use, I'll use the red one. We have two angles right here, 15 and 90. So 15 plus 90 is 105, and 105 subtracted from 180 is 65. All right. Questions? That's the wrong answer. It should be 75. How come I just caught that here? Because let's think this one through. 90 and 15 added together would be 10, 11. I'm sorry. I can't do math today. It's Friday. 5, pardon, and 10. So 105, and subtract that from 180. That's not 65. That's 85. 85 degrees. So the measure of angle ADE is equal to 75 degrees. So 75 and 105 would be 180. There we go. All right, fixed my mistake. I used this yesterday and no one caught that mistake, so it should be 75 degrees. Moving on to consequence number 2. Consequence number 2, this is the more challenging of the two, and that is that the sides of similar figures are in a proportion. That means a ratio, two ratios that are equal to each other. In other words, cross multiply. So all the sides. The hardest thing here is to figure out which side goes with which side. So one way you can do it is from the similarity statement. So the first two letters are A and B. That corresponds with side AB. So side AB goes with side DE. That kind of makes sense. Next two letters, let's see, that would be B and C. So B and C are right here, and B and C would correspond with, I'm following the same pattern, E and F. Makes sense. Last one, let's see, that would be, depending upon how you want to call it, AC or CA. I'm going to call it AC. So AC should correspond with FD, FD, and there you go. All right, and those are my three, or my all my sides written as a corresponding statement. Now, it does say that they are proportions. So that means they are, we literally can write a proportion. So if we were to write a proportion, right, these would be the proportions. Now, I'm going to go from small triangle to big triangle. You could take all of these fractions and flip them, and you would get exactly the same thing. right? Let's see, I'm going to go small to big. So side AB, that's the small triangle, goes to side DE of the big triangle. Notice I'm going small to big. And then I do the same thing for the other corresponding sides. All right, so those are my corresponding statements, and these proportions right here are how I basically solve for unknown sides. You saw this yesterday. So we set up a proportion. Here are two triangles that are similar. Notice that one of them has an X on it, so that is clearly the one that we're going to be solving for. And my recommendation is to always write the blank proportion. Start with the X, so X and its corresponding side. The side that it goes with is 8. So X over 8, right? X over 8. Then we go back to the triangle that we started with. We started on the big one. X is on the big triangle. I go back to the big one, and I pick any one of its other two sides that has a corresponding number on the other smaller triangle. I could pick 18 or 15. I'm going to always choose the smaller of the two because I like math with smaller numbers. And 15 corresponds with 5, and I write that proportion, 15 over 5. And now it's just a matter of a little bit of a cross multiplication in order to get the answer. So let's see, 5 times X is the same as 15 times 8. So click, darn you. 5 times X is the same as 15 times 8. Do a little bit of math. 8 times 15 is 120, and 120 divided by 5 is your answer. We okay? Questions, anyone? Let's see that again. All right, different triangles, they are still similar. Step number 1, I always start with the X and make the proportion. So X is right there. It corresponds with 3. So X over 3, that's its buddy. I go back to the triangle I started with. I started on the big one. You don't have to start on the big one, but I always start with the one where the variable is. I pick any one of the other two sides or any other given information that I am given that has a buddy. 12's buddy is 4, 6 buddies is 2. So I'm going to choose the smaller of the two, 6, and its buddy is 2. So 6 over 2. And that's what I'm going to set up for my proportion. So let's see, 2 times X is the same as 6 times 3. We solve that proportion, 2 times X. 2 times X is the same as 6 times 3. 6 times 3 is 18. Divide both sides by 2, and we get X is equal to 9. X is equal to 9. Questions, anybody? Sometimes it seems like when the teacher does one, they always pick the easiest of the examples, and then you get to homework and like, what? They didn't do one like this. If you run into a problem, don't hesitate. Send me a chat or an email. I'll be happy to give you some help. All right, let's see. This one right here is slightly more challenging, right? Notice that these are either been flipped or rotated. There is no triangle similarity statement, so you need to be careful, but I think you guys can match this up. If we were to rotate this one, either one of them, a certain number of degrees. Let me see if I can do that in PowerPoint for you really quickly. I'm going to do this in PowerPoint. This is what you would have to do in your head in order to match these up. Okay, so if I take this triangle, I got to make it look like the other one. If I rotate it that way, notice it doesn't look like it. If I rotate it, still, no matter how I rotate it, it actually doesn't look like the other triangle. Can you see that? Because what has actually happened is that, here's the magic of PowerPoint. What's actually happened is that it's not only been twisted and turned, it's been flipped horizontally or vertically. It doesn't make a difference. But if I flip it vertically, notice you can't read the numbers now, but now when I rotate it, ooh, look, now they look alike. Now they look alike. So it's been rotated and flipped. Now, obviously, it's hard to read the numbers here, but you can see what matches up. 4 goes with X. 5, is that a 5? Yeah, 5 goes with 30, and this is a 2. 2 goes with 12. Ooh, power of PowerPoint. What do you know? The issue with this is that a lot of times this is hard to do in your head. Sharing is paused. please bring it to your friend. So I don't know, maybe I lost the share there. Okay, that should be better. All right, so let's see. X is on the big triangle, and X's buddy we found out was 4. We pick any one of the other two sides. Obviously, I like the smaller. I'm going to pick 12. 12 pairs up with 2. Okay, so 12 over 2. That's the proportion that we need to do the cross multiplication on. So the cross multiplication would be what? 2 times x is equal to 4 times 12. 4 times 12 is 48. Divide both sides by 2. That gives us 24. All right, it is a Friday. We do have a little bit of reduced time, but Prudence, Jace, David, Angie, Abby, any questions? All right, nobody wants to talk to me. I'm sad, weeping. Angie, you're live?
Yeah.
All right. Okay, cool. And as we did this yesterday, I said that some people will look at this and they will simply say, hey, look, to go from a 2 to a 12, you're just multiplying by 6. So to go from a 4 to x, you just multiply by 6, and that is true, right? However, sometimes the numbers are not friendly, like in this one. To go from a 3 to a 4, well, many people can't figure out what that number would be. What times 3 is 4? So instead of worrying about that, just set up the proportion, right? X, it's pretty easy to see, goes with 11. I'm going from small to big triangle now, and 3 goes to 4. Order is critical here. If you decide to go from small triangle to big triangle on your first ratio, notice my first fraction right here, I'm going from the small triangle, X is on the small triangle, and I'm comparing it to the side on, or its buddy on the big triangle. So on this fraction, I got to go in the same order. I can't go big to small. I've got to go on from the small triangle again to the big triangle. And that's why I chose the side length of 3, because it's back on the small, and 3 goes with 4. If you flip those numbers around, you will absolutely get to the wrong answer. Cross multiply 4 times x is the same as 3 times 11. Ooh, ugly answer. Well, we knew it was going to be ugly because we didn't know what times 3 is 4. So we knew it was going to be an ugly fraction. So 33/4. Ooh, that's an ugly answer. If you change that to a decimal, it's 8.25. 8.25. All right. Anything left? We'll do one. I'll give you guys a minute head start, and then I'll work this one. 1 minute head start. Okay, I was just responding to someone. Okay, let's see what we got to go. Oh, look, they're both isosceles triangles. They both have side lengths of 49, 49, 7, and 7. Okay, so let's see. Make a proportion. X is on the big triangle, so X pairs up with 3. So X goes with 3. I go back to the big triangle. Pick any one. Well, the other two sides are the same, 49. So 49 would match to 7. 49 would match to 7. Big to small triangle, big to small triangle. We do our cross multiplication here. All right, numbers aren't that friendly here. 3 times 49 is equal to 7 times x. Let's see, 3 times 49, 3 times 9 is 27. Carrier 2, 3 times 4 is 12 plus 2, 147. And we're lucky because 7 does go into 147. 7 goes into 14 twice. 7 goes into 7 once, so 21 times. 21 times. So x equals 21. And for the smarty pants out there, yes, check it out. To go from 49 to 7, that's divide by 7. So to go from x to 3, you would divide by, so that didn't, well, let's do it the other way around. So to go from 7 to 49, that's multiplied by 7. So I multiply 3 times 7, and then I get 20. Look at that. That works sometimes. It doesn't work all the times. It only works when the numbers are nice and friendly. But when it does work, it is a bit more convenient than setting up a proportion. All right, that was it for today. We got spring break ahead of us. Since this is a second day of doing this and it is review, I would highly encourage you, since it's very fresh in your mind, to knock out this homework. Like we're ending with about, I don't know, 4 minutes left. To knock out this homework as soon as possible. If you wait to the end of spring break, either you'll forget about it or you will forget completely how to do this. If that's the case, remember this class is recorded both yesterday and today. You can look at either one. It's the same material. Look at either one and review that video or have it playing in the background as you're doing your homework. If you do have any questions over the break, don't hesitate. Send me a chat. Send me an email. I'd be happy to give you help on this. But absolutely positively have a wonderful spring break and be ready to come back. Finally, quarantine over. Be ready to come back, and we'll have about 8 weeks left of the quarter, and then summer begins. So end is in sight. Don't quit working. Make sure you do your homework, and I will see you guys when spring break's over.